Hello everyone, I'm Professor Ken Waksore. In this today's session, we are going to study a very interesting part which is the gyroscope. Gyroscope is the magic of physics. What is mean of gyroscope? What is its principle? What its effect on the different automobiles that we are going to study in this session? That when automobiles, in case of automobiles, which consist of the very high-speed rotating parts, and when they changes its orientation, then we need to consider the gyroscopic effect that I will explain you in the simple terms. You can just try to understand. This is one rotor. This is one rotor, which is the rotary mass. This is the disc now. But just try to understand. This is one disc having some mass and having some angular velocity. That means it is having some mass moment of inertia. Okay. Now what happens when this body rotates about its own axis, that which rotates like this, like this. Because of that conservation of angular momentum, that body tries to remain rotate in the same plane of rotation. That means it every time it tries to remain in the same plane of rotation. For that, I'll just try to give you one example. When you are moving on the two-wheeler, okay, when you are having the very high speed, that you are moving with 60 or 70 kilometer per hour with your two-wheeler, or yes, with your two-wheeler, at very high speed, you can move with the you can if you remove your hands from the steering, still your vehicle can move in the straight line path, that still your vehicle can move. But if you consider the same, if your speed is of the 5 kilometer per hour or the 10 kilometer per hour, in that case that body, that vehicle gets viable like this or like this. You need to adjust yourself, or you need to adjust the CG and the CG in that case to maintain that, to maintain the that stability of that vehicle. That means when your body is having some very high speed, having some speed, in that case that conservation of angular momentum maintains the stability of that vehicle about that vertical axis. In this case also it is remains same. When this body which is rotating about this axis, it tries to remain in the same plane. This is the same plane. That means, okay, and still if we allow to rotate this body, now this is the body which rotates about this plane. If we are changing the plane of rotation, plane of spinning, that means earlier it was like this, now we are just changing this plane of spinning about this vertical axis, then whole body gives some response, that resistance to that rotation, which gives about this third axis, and which is called as the axis of gyroscopic couple. And with that axis, that whole body either move like this or like this, like this or like this. There are the three axes. This is the axis of spinning, the body which rotates about this vertical axis, which is called as the axis of precession, and the whole body will, that is gyroscopic effect. Because of that gyroscopic effect, that whole body will rotate about the third axis, which is called as the axis of gyroscopic couple. In this way we have to study the gyroscopic principle. Okay, now what is the influence of this gyroscopic, or where are the application of this gyroscopic principle or this gyroscope? Okay, in case of electronic component also, you have seen that in your phone, that as you reorient, that means in the portrait, if you place your mobile phone like this, and if you reorient like this, still your that that home screen gets change its orientation. That means suppose in case of your YouTube video, you are just playing with the vertical orientation, and if you change the orientation like this, horizontal, in that case also that video gets changed automatically. In that case also you are using the gyroscopic principle to reorient that scene. Okay, again in case of, if you consider the mechanical part, in our aeroplanes, ships, because they are changing their orientation about this, they are taking the turn. In case of ship, because of heavy the tides, they are just pitching, or they are just rolling. To avoid that, to maintain the stability of this ship or the aeroplane, or in case of that cars, we need to use the gyroscopic instrument to maintain the stability of that vehicles or that automobiles. That means we need to add the gyroscopic instruments which nullify the effect of that that changing the orientation of that vehicle, and because of that you will maintain the stability. Again, the best example is of in case of Hubble telescope, which is the largest telescope. In that you will find the application of the that gyroscope. Again, in case of the submarines, in that also you will find the application of the gyroscope for their orientation. There are the two system in the two system we use the gyroscope. One is the inertial navigation system, and second one is the inertial guidance system. One is for the guidance and second one is for the navigation. For both the system we can use the gyroscopic instrument in the electronic system or in the mechanical system. Now we'll study the objective of this lecture. The objective of this lecture to know the or to give you the basics of the gyroscopic principles, and by knowing this principle that you can apply this principle in the design and the control system of the automobiles to like two-wheeler, car, ship, aeroplanes and the drones. In case of drones also you will find the application of, because to change the orientation of that drone or change the direction we need to use this gyroscope with the accelerometer for the changing the direction of that drones, that means quadcopters, etc. Okay, now okay, first of all, what is mean of gyroscope? If you consider the as a mechanical term, this is the gyroscope which consists of the disc or the rotor which can rotate about the three axes. This if we consider over here, one is this is the vertical is the, this is one axis, this is second axis and this is the third axis like this. This is the rotor, this is the spin axis, this is called as the gyroscopic frame, and this is the gimbal. With the help of this, that whole body, that rotor can rotate about the three axes. Okay, this part I have already considered. Where is the application? Again, in case of MEMS, also will find, that means electronic devices will find the application of the gyroscope. We will find how that in this case here in the animation that orientation of that plate is fixed, but that orientation of that gimbals are changed. That means if we fix the gimbals you will find the change in the orientation. That means if we fix the outer frame you will find the change in the orientation of the that rotor or the disc. Okay, in case of that automotive vehicles, that they turns with the high velocities, gyroscopic forces acts on the spinning parts such as crankshaft, flywheel, clutch, transmission gears, propeller shaft wheels. Engine parts as well as propeller and gear reduction system of the aeroplane are under the influence of the gyroscopic effect in terms of the pullouts. In case of ships also you will find the same effect. For this, that means in this session we are going to study, or in this total unit we are going to study the effect of that gyroscopic couple on the different bearings. Second, in case of that aeroplane, ships and the four-wheeler. Okay, now we'll consider different terminologies used in the gyroscope or while studying the gyroscope. There are the three axes. If we concentrate over here, this is the axis of spinning, this is the axis of precession about which that whole body is taking the turn, and that gyroscopic effect acting on this third perpendicular axis. These three axes are mutually perpendicular to each other. That means that axis of spinning, axis of precession and axis of gyroscopic couple which are mutually perpendicular to each other. Now we'll see one small within this visualization you will come to know. Suppose this is one body which rotates, or this is the rotor which rotates about in the anticlockwise direction about this axis, which is the axis of precession. Now it is taking the turn about the vertical axis which is called as the axis of precession, and the whole body will, because of that gyroscopic force, that whole body will rotate about the third axis which is called as the axis of gyroscopic couple. The plane which is perpendicular to the axis of spinning, which is called as the plane of spinning. Plane which is perpendicular to the axis of precession, which is called as the plane of precession, and plane perpendicular to the axis of gyroscopic couple, which is called as the plane of gyroscopic couple, like this. In this way, we will find the three planes and the three axes: axis of spinning, axis of precession, and axis of gyroscopic couple. Now, we'll just derive one expression how to find out that magnitude of that gyroscopic couple. Just consider this. This is one body which rotates about this axis with the angular velocity of omega. Now it's taking the turn about the vertical axis, which is the axis of spinning. Now, while taking the turn, its velocity also goes on increasing or decreasing, which is omega plus delta omega. Now, this is the omega, which is the axis of spinning. This is the axis of precession. Okay. Now we'll just join these two vectors. These are the velocity vectors, omega and omega plus delta omega. Okay. Now consider this OXA and this is XA. Now in this case, that AX, which is the one component of the acceleration which is acting along the that OX, and second component which is perpendicular to OX. This component which is along to OX, which is called as the tangential component, and that that perpendicular to the OX, which is this that gyroscopic component that we are going to study. Okay. Now alpha t is equal to, now if we consider the component which is along the OX, which is the AX, that horizontal component, just consider this triangle. On this horizontal is equal to omega plus delta omega cos delta. That means if we consider this triangle, this horizontal component, that OA is equal to omega plus delta omega into the cos delta minus omega, we will find this XA, and with respect to time we will find out the acceleration, angular acceleration. Okay, which is the tangential acceleration. Okay, now if we simplify this term, omega into cos delta plus delta omega into cos delta minus omega upon delta t. Okay, now as that delta is very small, sorry, delta theta is very small, that means cos delta theta is equal to 0, because for very small angles cos of theta is equal to 1. That's why omega plus delta omega minus omega upon delta t, that omega omega gets cancelled. That means your alpha t is equal to that d omega by dt, which is the tangential acceleration. Now let's consider the angular acceleration or the gyroscopic acceleration, which is the alpha c. Again, we need to consider the component which is perpendicular to this OX, which is the AX dash. AX dash is equal to omega, that means just consider this right angle triangle OAX dash, in which that delta theta is the included angle between this omega and omega plus delta omega. That means omega, that XA AX dash is equal to, this vector is equal to omega plus delta omega sin theta. This AX dash is equal to sin delta theta upon, if you want to find out this acceleration which is a limit with respect to delta t tends to 0. Okay, that means that alpha c is equal to, if you again simplify this term, omega into delta omega plus delta omega into delta theta. Okay, again that delta theta is very small term, again that delta omega is again small change in that omega. Because of this, but we can neglect this term because its product is very small. We will find one term which is the omega delta theta upon delta t. Okay, and this again, if we extend this limit, that omega into d theta by dt, again we know that d theta by dt, which is the rotation of this axis about the vertical axis, and that angular displacement which is of delta theta with respect to time, which becomes the omega p, which is the angular velocity of precession. That means when that aeroplane is taking the turn, while taking the turn, what is the speed of that while taking the turn, that we need to calculate, and which is called as the angular velocity of the precession, and this is called as the gyroscopic couple, which is the alpha c. Okay, then what is mean of, this is the gyroscopic acceleration, not the gyroscopic couple. To find out this couple, what we need to do, that to find out that couple which is again equal to the torque, that gyroscopic torque or that couple is equal to I into alpha. I, which is the mass moment of inertia, and alpha is this omega into omega p. In this way, we have to calculate the total gyroscopic couple. Now, now we are going to study the right hand rule, and with that right hand rule, we need to understand this gyroscopic couple. Now, just try to understand. This is for the example. This is the nose end of the aeroplane, and that observer which is standing over here towards the right hand side, and this is the three axis. These are the three axis. One is the axis of spinning, one is the axis of precession, third one is the axis of gyroscopic couple. Just try to understand that rotates in the rotor rotates in the anti-clockwise direction. Okay, this is very important. Just try to understand this, that rotor rotates in the anti-clockwise direction. Okay, now you have to just take your right hand, you have to consider your right hand, and you have to curve your fingers in the right hand in the anti-clockwise direction, and that thumb denotes the that velocity of that denotes the direction of that velocity vector, angular that velocity vector, which is the this red, and that you have to orient like this. On this you have to orient like this, which is the towards right hand, and this is the towards, which is the minus, that means towards opposite direction. Okay, next, now you are looking from the tail end. Though you are looking from the tail end, again that rotor rotates in the anti-clockwise direction. Okay, still again you have to take your right hand, you have to curve your fingers in the right in the anti-clockwise direction, and that thumb denotes the direction of that velocity vector, which is towards the direction. That's why that velocity vector is again towards the same direction, whether you are looking from the tail end or the nose end. If that rotor rotates in the clockwise direction or the anti-clockwise direction, using this you need to find out that direction. Okay, now again you are looking from the nose end, and rotor rotates in the clockwise direction. Just try to understand the clockwise direction. In this way, you need to rotate your right hand, rotate the fingers of your right hand in the clockwise direction. If you rotate in the clockwise direction, the again thumb denotes the vector. That vector is like this. In that case, you have to draw the axis of spinning in this direction. Again, you are looking from the tail end. That rotor rotates in the clockwise direction, and using this, you need to give the axis of spinning towards. You have to define the direction of rotation or the direction of the axis of spinning. Okay. Now we'll consider the axis of precession. Okay, that means rotation of that aeroplane about the vertical axis. Now again in this case, that rotor rotates in the clockwise direction, that vector is toward this. Okay, now that aeroplane is taking the left turn, not the left towards the left of ours or the observer. That aeroplane is taking the left turn of its own. This is the left hand side of the aeroplane, and this is the right hand side. Okay, now it is taking the left turn like this. That means this is the anti-clockwise direction. That means what we need to do, you have to rotate. This is the axis of precession, because that aeroplane is taking the turn about the vertical axis. That's why this is the axis of precession. Okay, now the next part we'll discuss later, but in this way you need to decide the axis of precession. In the second condition, that rotor rotates in the anti-clockwise direction, and that aeroplane is again taking the turn towards left. Okay, again this is the axis of spinning. That means that you need to rotate that axis of spinning in the anti-clockwise direction, because this direction is the anti-clockwise direction. This direction, the direction of this arrow denotes the anti-clockwise direction towards left. That means the anti-clockwise direction. Anti-clockwise. Again, that observer is standing over here. Rotor rotates in the clockwise direction. That vector is moving like this, which is towards left. that orient towards left, that aeroplane is taking the turn towards right. Towards right, that means this direction is the clockwise direction. If we check the direction of this arrow, this direction is the clockwise direction. That means you need to rotate that axis of spinning in the clockwise direction. That we'll discuss later, but just try to understand the axis of spinning. Again, in this case, rotor rotates in the anti-clockwise direction. That's why this vector is towards right. That aeroplane is taking the turn towards right. Towards right. That means that towards right means this direction is the clockwise direction. Okay. Now we'll study the effect of the gyroscopic couple. In this is very interesting and this is very important. That rotor rotates in the clockwise direction when viewed from the nose end. Now you are standing over here. That rotor rotates in the clockwise direction when viewed from the nose end. Okay, that rotor rotates in the clockwise direction. Okay, now you have to orient your right hand in the such way that you have to rotate your fingers in the clockwise direction. Clockwise direction. Okay, when you rotate your fingers in the clockwise direction, the direction of thumb denotes the velocity vector. Velocity vector. This is your velocity vector. Okay, now that aeroplane is taking the turn towards left. That means that axis of precession which is in the which that means that ship is rotates in the anti-clockwise direction about the vertical axis. When you are viewed from the top axis, you will find that ship is rotating in the anti-clockwise direction. Okay, that means this is the axis of spinning which is the anti-clockwise direction. That means what you need to do, you have to rotate this axis of spinning in a anti-clockwise direction till it approaches to the third axis, like this. Now this is your axis of the active gyroscopic couple, and this is the axis of the reactive gyroscopic couple. This is the axis of the reactive gyroscopic couple. Okay, now this is the reactive gyroscopic couple. Now what we need to do, again you have to take this reactive gyroscopic couple in this way. Again, now you need to consider the direction of axis of the reactive gyroscopic couple. Just try to understand, we need to consider the direction of reactive gyroscopic couple. Here you will find that active gyroscopic couple, you have to just take the opposite of that active gyroscopic couple. You will find that orientation of this new reactive gyroscopic couple, and you have to take this like this, and you need to orient your right hand again in the same direction which is perpendicular to the plane of this your mobile or your screen. Okay, if you orient it like this, that thumb that denoting or which is pointing towards your that screen, and the direction of fingers which is like this, and which change the direction of that total aeroplane which is like this. That means that Euro nose of the aeroplane which is dipping down, and raise or tail which moves in the upward direction, which raises. That means dip the nose, raise the tail is the gyroscopic effect for this condition. When that you are looking from the nose end, rotor rotates in the clockwise direction, and that ship is taking towards left turn. For this, you need to study this axis of spinning, axis of gyroscopic couple, axis of precession, and using this concept, you need to find out the actual gyroscopic effect acting on that aeroplane. Okay. Now in the second, just try to understand. You are looking from the tail end. Rotor rotates in the clockwise direction, and that aeroplane is taking the turn towards left. You are looking from the tail end. Rotor rotates in the clockwise direction. Rotor rotates in clockwise direction. Again, you have to take your right hand, and you have to rotate your fingers of the right hand in the clockwise direction. If we rotate the fingers in the clockwise direction, that velocity vector which is denoting towards left hand side. That means you have to orient your axis of spinning towards left hand side on the axis of spinning. Now that this is the front end, this is the nose end, and this is the tail end. Now this is the left hand side, this is the left hand side, and this is the right hand side of that ship. And that ship is taking the turn towards left like this, in this direction, towards left like this. Okay, that means if you consider this direction of orientation of this circular arrow, which shows the anti-clockwise direction, anti-clockwise. Okay. Now, what is the significance of this? You need to rotate this axis of spinning in the anti-clockwise direction till it approach to the axis of gyroscopic couple. Okay. Now you need to rotate this in the anti-clockwise direction, like this. Now with this you need to rotate this axis of spinning in the anti-clockwise direction. This is the anti-clockwise direction, and we will find this is the axis of active gyroscopic couple. When we rotate this axis of spinning, we will get the axis of active gyroscopic couple, and just opposite of it, you need to take, this is the axis of gyroscopic couple. On that, you have to just take the opposite of it, which is the, you need to take axis of the reactive gyroscopic couple. Now, what we need to do, again, you have to just assume you have just placed that vector in your hand, and that the direction of this vector, which is just towards which coincides with your thumb direction. Okay, and you have to curve your fingers on this vector, and if just like this, and that finger shows which direction. That finger shows the clockwise direction. That means this is the aeroplane, and you have to rotate that aeroplane in the clockwise direction like this. This is the clockwise direction. That means the ultimate effect of this gyroscopic gyroscopic couple, which is of raise the nose, dip the tail. That means because of this gyroscopic effect, that aeroplane will move in the upward direction. Nose of that aeroplane will move in the upward direction, and that tail will move in the downward direction. In this way, this is the one part of this gyroscopic principle. In this way, in this session we have started with the basics. We have studied its derivation, that alpha c, that means gyroscopic acceleration, is equal to omega p, where omega is the angular velocity of that vector and omega is the precessional angular velocity. Then we have studied there are three axes. One is the axis of spinning, second one is the axis of precession, and third one is the axis of gyroscopic couple. These three are the perpendicular to each other. Then we have started with how to use that right hand thumb rule to orient that velocity vector, and we have end with the gyroscopic effect on the aeroplane. With this, I'll just finish my session over here. Thank you very much for your patience listening. Thank you.